In this problem, we have a single turn loop, a radius 4.75. So this radius from the center of the loop out is 47.5 millimeters, lies in the plane perpendicular to spatially uniform magnetic field. So B dot N is just B, B dot N hat. During this little time interval, 0.345 seconds, the magnitude of the field increases from 180 to 448 millitesla, right? So, if we take the magnetic field to be out of the page and our counterclockwise current to be positive, right? So this magnetic field is coming out of the page. It is increasing, and so the EMF induced is going to be induced to cause a current. Which direction? Well, the current, since this magnetic field is increasing, the induced current is going to create a magnetic field that opposes that increase and be pointed into the page, right? Well, the current that does that is a counterclockwise current. By the right-hand rule, if you poke your thumb into the page, your right hand, your fingers wrap around in the clockwise direction, and so counterclockwise is positive. That means this current is going to end up being negative. We have the resistance of the wire. We have everything we need to calculate the EMF. So EMF is going to be minus N, and then this d phi dt. Well, this, since the area of the loop is not changing, we can rewrite this as minus N times the area dB dt. Right? Since the area is constant, we can write it as dB dt, A times dB dt. And dB dt is this final B field, 448 millitesla, minus the initial B field, 180, divided by the amount of time it changes over, right, 0.345 seconds. So we know dB dt, we know the area, we can calculate the area, right, pi r squared. Make sure you convert that to meters, make sure you convert that to Tesla, and we know it's a single turn circular loop, so N is 1. That gives us the EMF. Once we have the EMF, right, we know the resistance, 18.41 milliohms, have to convert that to ohms, determine the current induced in the loop, and we've already decided, right, that the current induced in this is gonna have to be clockwise, it's gonna have to be clockwise, because it's opposing this change, this increase in magnetic field. So the current induced is producing a magnetic field into the page to oppose the magnetic field that's coming out of the page. Right? Magnetic field's increasing out of the page. The induced current creates a magnetic field headed into the page to oppose that change. And that current in this case is going to be clockwise, so it's going to be negative because we defined counterclockwise as positive. And that's it for this problem.